Let's do the last example, example 19, which is going to be another example of how to calculate a probability for the sampling distribution of the proportion. So similar to the last example, example 18. So this one says, according to a certain news report, 44% of US adults believe there is intelligent life on other planets. If a random sample of 200 adults is selected from this population, then determine the probability that the sample proportion of adults who believe there is intelligent life on other planets is, and then we have A, B, and C. Let's forget about the question for a minute. This is what we always do, right? First, we identify who's your population, what were we told about the population, are we taking a sample? So our population is US adults. That's the group that we're studying, right? US adults. We're being told that 44% of these adults in this population believe that there is intelligent life on other planets. So we're being told that the population proportion of adults that believes there's life on other planets is equal to 44%. So this is, P stands for the population proportion of US adults that believe there is intelligent life on other planets. So that's what P stands for in words in this case. And we're being told that P is equal to 44% or 0.44, right? Now we're going to take a random sample of 200 adults. So we're going to grab N equals 200. And we want to determine the following. A, what's the probability that the sample proportion of adults who believe there is life, intelligent life on other planets, is less than 42%? So let's put this sentence in English right into mathematical notation. So we're interested in the probability that the sample proportion, which is P hat, right? Because it's a proportion coming from that sample of 200. So the sample proportion of adults that believe there is intelligent life on other planets is less than 42%. So we want to find the probability that the sample proportion P hat is less than 42%, or as a decimal, 0.42. So typically I usually write things in decimal form because when we go to plug it into a formula in the calculator, we have to convert it anyway. So I just do it now. So in order to answer this question, we need to know about the random variable P hat, right? My sample proportion P hat is like the star of the show right now. That's the variable, the random variable of interest. So we have to describe it. So we need to know the shape, the mean, and the standard deviation. So we need to check that n times p is greater than 10 and n times 1 minus p is greater than 10. So n is 200 and p is 0.42. Nope, I'm sorry, p is 0.44. I'm looking at the wrong spot. So our population proportion p is 0.44 and 200 times 0.44 is 88, which is greater than 10. That checks out. And now we have to check that n times 1 minus 0.44, or 1 minus p, is greater than 10. And this is going to be equal to 112, which is greater than 10. So that checks out as well. So since both n times p and n times 1 minus p are greater than 10, we could apply the central limit theorem, which states that p hat is approximately normal. So I feel comfortable sketching my normal curve. And the mean of all the p hats goes in the center. And mu sub p hat is equal to p, which is 0.44. And now we have to calculate the standard error of the proportion, which is going to be the square root of p times 1 minus p over n. So that's going to be the square root of 0.44 times 1 minus 0.44 over n, which is 200. And I want you guys to plug that in the calculator. So we're taking the square root of 0.44 times 1 minus 0.44, and we're dividing that by 200. And we get about 0.0351 for the standard error. Now we're ready to sketch the area under the curve that corresponds to p hat being less than 0.42. So 0.42 is to the left of the mean of 0.44. So let's say this is where p hat equals 0.42 is. Sorry, this pen's a little glitchy right now. All right, so we want the probability that p hat is less than 0.42. So I'm shading the area to the left. Now, since we're dealing with the normal distribution, even though my variable is p hat, it still follows a normal distribution. So we could use normal CDF to find the area of the shaded region, right? So we're going to pull up normal CDF. We need to tell it the lower and upper bound on the shaded region, right? So since we're coming in from the left, the lower bound is going to be negative E99. The upper bound is going to be 0.42. The mean is 0.44. And the standard error is 0.0351. And we could plug that into the calculator together. So let me pull up my calculator. I'm pulling up normal CDF. The lower bound is negative E99. The upper bound is 0.42. The mean is 0.44. And the standard error is 0.0351. And my area is going to be about 0.2844. And remember, area under the normal curve corresponds to probability. So my answer, and you know what? I'm going to put the answer here in red so it stands out. 0.2844. So that's the answer to part A. So the probability that the sample proportion of adults that believe that there's life, intelligent life on other planets is less than 42% is about 0.2844. So let's look at part B. Part B says, what's the probability that the sample proportion of adults who believe there's intelligent life on other planets is between 0.46 and 0.51, or 46% and 51%? So part B, we want to find the probability now that p hat is between 46% and 51%. So 0.46 and 0.51. Now, we already did most of the work in part A. We know p hat is normal. We know mu sub p hat is 0.44, and the standard error is 0.0351. So I'm going to sketch the same curve. with mu sub p hat equals 0.44 in the center. 0.46 is to the right of 0.44. So let's say this is p hat equals 0.46. And 0.51 is to the right of that. So let's say this is p hat is equal to 0.51. We want to shade the area between. So that's the area under the normal curve that we're looking for. Now my lower bound is going to be 0.46 and my upper bound on the shaded region is going to be 0.51. So let's go to the calculator. We're going to pull up normal CDF again. My lower bound is 0.46. My upper bound is 0.51. We have the same mean of 0.44 and the same standard error of 0.0351. And the proportion is about 0.2613. So the probability that the sample proportion of adults who believe that there is intelligent life on other planets is between 0.46 and 0.51 is equal to about 0.2613. And let's look at the last part, part C. What's the probability that the sample proportion of adults who believe there is intelligent life on other planets is greater than 50%? So now in part C, I want to know what's the probability that p hat is greater than 50% or 0.50 as a decimal. So let me sketch my normal curve. I know p hat is normal. I know the mean, mu sub p hat is equal to 0.44. We want to know what's the probability that p hat is greater than 0.50. So 0.50 is going to go to the right. So p hat, let's say, is equal to 0.50. And we want the probability that p hat is greater than 0.50. So that's going to be the area to the right. So we're working with normal distribution, so we could use normal CDF. The lower bound on this shaded region is 0.50, and the upper bound is going to be positive E99 or infinity. And now we could plug into normal CDF in the calculator. So we said the lower bound is 0.50. The upper bound is E99. The mean is 0.44, and the standard error is 0.0351. And my area under the curve is 0.0437. So 0.0437. And that corresponds to the probability that the sample proportion is going to be greater than 50%. So that is just another example of an application question involving sampling distribution of the proportion. So in all three instances here, think of the star of the show as p hat, the sample proportion. That's my random variable. And in the first half of chapter 8, the star was x bar, right? We were looking at the sampling distribution of the mean, and x bar was the random variable. So it all depends on the question. In these questions, right, we were always interested in the sample proportion, and that was the key word for each one of these. So this wraps up chapter 8. In the next lecture, we're going to begin chapter 9.